This is a video learning how to do a confidence interval for slope and how to read minitab outputs for slope hypothesis tests. The confidence interval for slope is very similar to other formulas. It's found on page 644, 645. There's an example there as well. We take our point estimate, which is the sample slope, and we do plus or minus the t-score, which again, if sample size is large enough, t will be the same as z, and multiply by the standard error for the sample slope. And again, this particular number is going to be given to us in some form or fashion. Let's start with the minitab output. Father's age versus mother's age. Regression equation will show how old we expect a mother to be based on the father's age. So we have all these data points from a sample. Father's age is the X number, corresponding mother's age is the Y. The regression equation will tell us on average what we expect the mother's age to be. Slope tells us that for each year older a father is, the corresponding mother's age will be 0.66576 years older. Sample size is 446, so again, very large. We're going to basically be using Z here because it's so large. Now here's a minitab output. This output has a couple numbers that are very crucial and some that are completely irrelevant. This top row that I've highlighted, the constant row, is meaningless. That is for if we want to run a test about the y-intercept. This 14.542 is the y-intercept. This is the spread for the y-intercept, the t-score, and the p-value, but we're not testing the y-intercept, we're testing slope, so that first line means nothing for us. Second line, father's age. This is what we want to test, the relationship between mother's age and father's age. We have several numbers here. Let me scroll up and you can see I have them labeled. The first question says label each number in the output. 0.66576, this number right here, the coefficient, that is your actual slope. The next number, 0.02571, that is the SE for the coefficient, or the spread, the standard error for the coefficient. This is your SE sub B sub 1, standard error for the sample slope. So these are the two numbers that we would be using to calculate T. And if you divide these two, you get your t-score. So the 25.89 is the t-score, the test statistic for the slope test, and of course the p-value for the slope test, and that's 0. 0.781, correlation value R. It's the Pearson correlation between these two variables. 0.781, moderately positive, moderately strong positive relationship. And I have S, 3.288. That is your S, the typical residual size. So again, don't get these two confused. SE sub B sub 1 is up here. Typical residual size is down here. And then, of course, R squared. We talked about that earlier this year. We're not going to be using that right now. All right, so the first question, what is the relevant test statistic? It is not the 11. That is for the y-intercept. We are interested in this one, 25.89. That's the t-score. P-value is 0. Obviously, it tells us what our conclusion is going to be. We'll get to that in a moment. I'm going to find the confidence interval. So my formula, b sub 1 plus or minus t times SE sub b sub 1. So I take my sample slope from the output, 0.66576, plus or minus, and I'm going to use 2. I'm going to do a 95%. And because the sample size is so large, the t-score is going to be the same as z. It's going to be approximately 2. If it's not big enough, we're going to use the t-chart, and we'll see that in the next example. Do not use the t-score from the test. This is the t-score from the test. That is not the t-score that you use in the confidence interval. The t-score you use in the confidence interval comes from the charts, based off of the confidence level. 95% is 2. If you're doing 99, you would do 2.576. Okay, so again, do not use this t in your confidence interval. You get it from the chart. Now when I run these numbers, plus and minus, I get this interval. So let's see what that interval tells us. What conclusion can you make? If h sub o is true, there is a 0% chance that the slope would be what it was. So we have strong evidence, slope is 0, that there is a moderately strong positive relationship that goes back to the r value between the two h's. What does the interval tell us, though? And here's the wording we want to use. Specifically, the interval always tells us how big the difference might be when we're doing a two-sample. There's other ones. Well, what we're talking about here is that difference as far as change in y over change in x, the slope. So we're going to phrase it with the same wording that we would use if I asked you the question, what does a slope mean? As what is y doing as x increases by 1? So what we're looking at is we are 95% confident that for each additional father's age, for each additional x, the corresponding mother's age will be 0.614 to 0.717 years older. Okay, next one, typical error size. Another way of saying typical residual size, that's the 3.288, and that's S. Does the regression predict higher or lower mother's age for a higher father's age? And we know that it's going to be a lower mother age because the slope is less than 1. Okay, let's do one more example. I see another output here. This is pertaining to evacuations. The duration of the evacuation, how many minutes it lasts, is the x value. How much that costs the airport, the economic impact of a airport being closed and evacuated is determined by the duration. So the longer it lasts, the more it's going to cost in an economic impact. So the slope is positive, of course. So again, looking at the input or the output, this top line means nothing. That's about the y-intercept, and I don't need it. I'm focused on this second line. Here's my slope. Here's s e sub b sub 1, the spread of the slope. We're going to find t and p in a moment. They didn't give us r this time, but we can find r by just taking the square root of 0.854, like we did earlier this year. I do have typical residual size, that's 0.7. Pretty small spread. Find 95% confidence interval. Okay, the first thing we got to recognize is that in the problem, there were 10 evacuations studied. So the sample size is only 10. So what we have is degrees of freedom of 8. So t is going to be 2.306. Let me show you that real quick in case you've forgotten how to use the chart. Degrees of freedom here is n minus 2 or 8. So I'm looking at degrees of freedom 8. I'm using a 95% confidence interval, 2.306. Again, it's 90, 95, 98, 99. So for degrees of freedom 8, we want 2.306. So here's my t-score, 0.05562, that's my slope. SE sub b sub 1, the spread of slope, is from right here. And I run those numbers, I get these values. There's my interval. What can this interval tell me? We are 95% confident that for each additional minute, for every minute that they're out, that they're evacuating, that the airport is in evacuation, it will cost between $36,897.59 and $74,342.41 per minute. Each minute is going to cost somewhere in that range. So let's say you were evacuated for, the whole evacuation took 30 minutes. You would multiply this number by 30 to find out what's the most it might cost. This number by 30 to see what's the least it might cost is the best case scenario. Obviously still going to be a lot of money. What would be missing, the missing t value be based on this interval, and what would the p value be? And again, the t value, we do sample slope minus 0 divided by the standard error. This is just like the formula we used last week. So really, in a minitab output, you're just taking these two numbers and dividing them. The slope divided by the spread of the slope. Divide those two numbers and it gives me t, 6.85, and then I can figure out p, which in this case would be 0. Now, last question. Watch the wording here. These are the kind of questions he likes to ask in case you run across this, especially when we get to the final. Altogether, there were 120 evacuations that year. in American airports. The slope of the regression line for the relationship between duration and cost for all, so we're talking about the population now, for all 120 evacuations. What can we conclude about the population? Is the slope of the regression line this? And the answer is no, because that's the sample slope. We don't know that that's the slope for the population. It's unknown, but it must be positive. Well, yeah, it must be positive because the p-value is 0. Well, no, it doesn't have to be. There is a 5% chance that we missed the mark, that we maybe got our test wrong. So it's option 3. It's unknown, but almost surely positive. We're very, very confident, but we don't have full proof. So watch the wording there. And of course, it can't easily be negative. If it was easily negative, then this interval would have 0 in the interval. It would be negative to positive. 0 would be in an interval, and the p-value would be large if it could easily be negative. Make sure you complete the assignment for this. There's only one question, pretty short.